Hello, everyone, and welcome to another episode of the Real Estate Development Insights podcast, where we share ideas, experiences, and insights about the real estate development industry. My name is P.Eng, and I'm very happy to be your host here. Our guest for this episode is Cara Sloat. She's a Toronto-based mechanical engineer and a principal at Hammerschlag and Joffe. Hopefully, I'm saying that name correctly, which is a large mechanical and electrical consulting firm that works all over Canada. She has more than 20 years of experience designing mechanical systems, and she especially focuses on low-energy buildings, decarbonized multi-residential units, and commercial buildings. Her experience in ventilation includes exploring innovations in fresh and clean air delivery. She took the responsibility throughout the COVID-19 pandemic to gather and communicate the latest research on indoor air quality and safety to her peers at ASHRAE, which is an international organization that leads in creating ventilation safety standards. Cara also serves on the board of the Toronto's 2030 district, and she's an alumni of University of Waterloo. And this is an awesome episode, and all the credit goes to Cara for the knowledge, insight, and frankly, the spirit that she brings to our discussions. She's very passionate about the topics of design, efficiency, and how they affect the environment and how we can use them wisely, hopefully, to mitigate the effects of the climate change and the climate crisis that we're going through right now, the actions that need to be taken. And she also talks about how you can effectively and efficiently engage the services of a mechanical engineer or electrical engineer early on in your project so you can benefit as a developer, as someone who's designing the new building. And we cover a lot of ground in this discussion. It becomes a little bit technical at some points, but it's worth it. Trust me. This episode was awesome. We talk about the geothermal or geo-exchange systems, how they work. We talk about heat pumps and the refrigerants, how they work. We talk about the requirements of something like LEED and how they can lead us, no pun intended, into designing better buildings. And last but not least, we talk about some low-hanging fruit that anyone can tackle and go after so they can come up with a better building design. And in a nutshell, if you're at all interested in learning about mechanical systems in buildings and how they affect your experience as someone who lives in the building and the effects of that building on the environment surrounding it, we're going to have a lot of valuable information for you in this episode. You can find more information about this episode on our website, realestatedevelopmentinsights.com. That's all one phrase, realestatedevelopmentinsights.com. And I hope you enjoy listening to this episode. Please remember to subscribe to the show and enjoy. Thank you. Hi, Cara. Welcome to the show. Thank you for being here.
Thanks for having me.
So, Cara, you and I are currently working together on a project. You're the mechanical engineer, and we'll dive into that in terms of your experience. But like I was mentioning to you just before we started recording, is that one of the benefits of these episodes is that I actually get to research people that I want to talk to, when I typically try and find things that I normally wouldn't find about them. I came across this phrase that you have. So Cara Sloat is a philosopher, martial artist, urbanite, and cycle commuter. A couple of them are really interesting to me, and the main one is the philosopher. Can we start from that? And then we go from there?
When I was a kid, I always thought I was going to go into the arts. So I was getting this engineering degree because physics was really fun. And if you get really good grades, they tell you should do something with them. So if you apply to like physics and philosophy, you need a low 70s average. In mechanical engineering, and I couldn't tell the difference between mechanical engineering and physics, you needed a high 80s. And so, being an explorer, I said, well, you know what? I'll just apply to that program. And then when I figure out what it is, I can always get into physics later. I had no idea what mechanical engineering was when I started, but I do have a book called The Philosophy of Fluid Mechanics.
Oh, you actually have a book called... Okay, so you are a philosopher. That's not just a false claim. It's not an ambition. It's actually...
No, I have the majority of a bachelor's degree in philosophy.
Wow.
I'm not going to name the specific school of philosophy I learned I didn't know enough about until I got into a class and couldn't pass it because I couldn't write a paper that the professor would agree with because I thought he was so wrong about the entire world and his worldview that I just had to walk. But, most of an undergraduate degree in philosophy. In fact, one of the things that he believed was that the engineers would fix climate change so we didn't need to do anything about it.
So you decided to become an engineer and actually be part of the solution then?
I was an engineer and I threw my hand up and I was like, I want you to understand that you are an expert in some things in this class and I am an expert in some things in this class and climate change is not one of yours. So the thing about philosophy that's really interesting is it was the only way we knew how to figure out the world in ancient times.
That's very true.
Yeah, in ancient times, mechanical engineering was in philosophy, chemistry was in philosophy. What else was it?
Some sort of all-encompassing type of science, and I guess ideology as well, right?
That's it. So the only thing that philosophy is really holding on to is ethics right now. And ethics is slowly but surely, carving itself out into its own discipline. So I don't know. I love philosophy. I think it's really important to understand why we're here and why we're doing what we're doing.
So that's actually a very good segue for me to use. You had good grades. You liked physics. You fell into mechanical engineering. I guess you might have somewhat answered this already, but let's expand on this. When I was looking you up and your history, you have more than 20 years of experience in mechanical engineering. And it seems to me that you have tried to zero in and focus on, like you mentioned, climate change. And I think the proper terminology is low energy mechanical systems, if I get that right.
That is correct.
And maybe let's expand on that a little bit. Was it a philosophical choice?
Absolutely.
To go in?
Yeah.
Okay. Good.
I mean, there's a challenge to it. There's kind of two parts. Both, it's the right thing to do, but also it's really interesting. Designing something that will heat and cool a building is not that hard, but designing something that will do it using the energy that the systems that were being installed when I got into the industry, that's a lot harder. So being able to spend my time on challenging engineering problems and spend my time in rooms with teams of 15 or 20 people, everybody working together towards a single goal. This part of engineering has a lot of social connection and integration to it. And I love both that challenge and also the fact that there was just slightly more meat to designing net zero buildings than there is to typical design.
So what would you say in terms of if you were to say there's a spectrum of what Cara expected to be able to see or witness or be part of during her career in this, one being where you started, probably not so good to begin with, 100 where we need to go to have no issues. Where would you say on that spectrum are we right now?
Oh, such a fascinating question. So when I got into the industry, I would say that we were paddling in the opposite direction. I had a mentor named Greg Allen who ran a company named Sustainable Edge, which was the first place I worked after I got out of school. And we felt like we were pushing against the tide. So there was a lot of forces in the industry that didn't see why we should decarbonize at all. And in the last 5 years, I think the confluence of, it isn't a confluence. The fact that we can see climate change, the fact that every summer now there are forest fires and the smoke is bad enough that it's sweeping over Toronto, despite the fact that the forests that are on fire are hundreds of kilometers away. And the fact that we're having heat waves that are record setting, and that's been happening year after year for decades. The fact that we're getting flooding that is unprecedented. It feels like having the climate actually change has convinced people that the climate change advocates, climate change scientists were not.
It was not just a theory. Unfortunately, we're actually feeling it. We're seeing it. We're breathing it, right?
We are breathing it. So we had an opportunity when I got into the industry to fix it before the climate changed. And now we have the opportunity to decide how much climate change there will be. So 2 degrees Celsius is essentially unstoppable, but it doesn't need to go to 3, doesn't need to go to 4. I think the difference between 2 degrees and 4 degrees is going to be the difference between a livable planet and something that doesn't look like the place where we have society today. So we're still in the midst of a really, really big change. And
we still can do something about it, is what you're saying. We can impact it significantly enough, hopefully, right? Did they get that right?
Yes, that's right. We are at a decision point in the next 10 to 15 years, the way that each of us in both the development sector and everywhere else make decisions about how we interact with fossil fuels is going to make the difference about whether or not the planet remains at the temperatures that we evolve.
Right.
Yeah, it's a big deal. But the exciting part is people are building net zero buildings. People have just come to us and asked us, what do we need to do? And at the same time, in the last 20 years, the engineers, the ones who really wanted to get into product development, not a place that I ended up, have created solutions that are easily deployable, that are ready to go, that we can just install in buildings. So it's been really heartening in the last, I would say, 5 years to see the right technologies be combined with the right attitude and developers actually moving forward with really low carbon technologies.
That's perfect. So if I may,
yeah.
So like you said, I first of all, I totally agree with you that I've also been doing this for a long time right now, and for the past few years, this is the first time that talking about climate, talking about energy efficiency is not just let's meet the bare minimum code. It's actually something that people are feeling, you know what, we need to do something about. But let's start with that. Let's pretend that I'm a new developer. I'm not a new developer. I have done development, but I have a new project. I'm coming to you, Cara, and I know that you are an advocate of having the mechanical and electrical engineers engage in the process very early on, and we can talk about that. And so I'm going to come to you, Cara, or another mechanical engineer, and what are the first things I should be asking you? Let's pretend for a second that I really don't have that much background in construction or engineering, and I need to be guided, if you may. I need to be coached, right? What are the things I should be looking for? What are the questions I should be asking my consultant? And let's start with that and go from there.
So I'm going to back up just a touch and say we've started on climate change, but climate change is only one part of what you should be talking to your mechanical and electrical engineers about. So,
what is the other part?
Which system is right for your building? What you
perfect.
should be buying? Yeah, it's a little like, so yeah, you need an electric car, but which one? What kind of capacity do you need? Depending on what building type you have, depending on what investment class you're in, there's going to be a big difference between what you want for a condo compared to a long-term hold, own, operate. A big difference between what you're going to be putting in if you're building an office building or even something that's got a lot of different mixed uses compared to something that's fully residential, for example. And talking to your mechanical engineers about what your ambitions are for future ownership, who needs to control what in the building, will help them guide you to a solution that's got the right combination, I'm going to say controllability, modularity, reliability, simplicity.
Sorry, controllability, modularity, and simplicity. Right? Can we dive into those a little bit? When you say controllability, what are we talking about? Are we talking about having smart thermostats in the units?
Or even being able to control the temperature significantly within a suite. If you're doing multi-bedroom housing, do you want to be higher end? Do you want to be able to tell people they'll be able to have different temperatures in the bedroom compared to the living room? Or is it going to be okay for all of those to have the same temperature? Do you, as the building operator, want to know what temperatures your tenants are providing? Do you want to be able to submeter them? All of those questions will help guide which mechanical system you're going to be looking for.
Right. And when you talk about modularity, what are we talking about there?
So for me, that's how much of the system that I put in place will be owned by the base building owner, so the developer.
Gotcha.
And how much gets downloaded into an individual suite by suite ownership. So when you hand the building over, how much of that mechanical system ends up being an asset that's held by the person in the suite.
So maybe can we explore that a little bit? How would you say? Obviously, there's a financial aspect to it. There's a capital investment side to it that many developers and I'm going to open parenthesis here is that some of the developers or many of the developers these days if you're building a condo, they would go for rentals, for example, for heat pumps. So they come with the rental program. So technically, the like all the equipment in the units are rented from some suppliers and third party agencies there. But from a design perspective, from an efficiency perspective, maybe walk us through why is that important to you, to your team, and like why would we care about that other than the capital investments?
Well, for sure, you can get better efficiency out of central systems. There's a couple of other really big elements that I think you probably heard me talk about, which is that there is going to be a huge issue in the electrical capacity of our grid. This is maybe a Canada-specific and Ontario-specific problem. We are talking in Toronto. We do a lot of development here. The connected load of some mechanical systems, specifically ones where the compressors are in the suite and each person owns their very own heat pump, whether or not it's owned or rented, is significantly higher than if you have a central system, because essentially the sun moves around your building, and at each moment of the day, the east side is going to need, a full ton in each room, and then the south side is going to need a full ton, and then the west side needs a full ton. So as the sun moves around the building, if you bought a central system, you're only buying 1 ton to cool the place where the sun is shining. If you've put the compressors in each suite, you had to buy 3 tons. And then you had to connect it to the electrical grid. So you can see a doubling of the connected electrical load, which may be enough to change the service size. Those come in very specific numbers, right? You're going from a 400 to a 600 to an 800 to a 1200 amp connection. So the mechanical system choice you make could take you up one service size, which can add hundreds of thousands of dollars to a project.
That's true.
So, that's the one side of that coin. The other side is when people, especially if you're trying to develop a reputation as a quality builder, you want to have not just your first project sell, but 5 years later, 10 years later, you want the reputation of those units in resale to remain high. So if you've got really high condo fees because all of the equipment is central, so the reserve fund is taking like large amounts of money from everybody every year to plan for all of those assets, it's very tangible for owners in a way that in-suite equipment that doesn't have a condo fee attached with it, it's just that at end of life, the individual suite owner has to pay for it, is not going to be visible in the same way. So thinking about where the money shows up in people's balance sheets and how that impacts your market reputation, it can be important. And so many condo developers find that investing the extra money in the higher connected load may be appropriate because in-suite heat pumps download that cost to the owners in a way that's appropriate for the way that they plan their capital investments, right? The other thing about go on.
It's very complicated, but sorry, I want to make sure I get this concept right. But I think I understand what you're saying is that basically the market economics of having to resell a condo means that you want to keep the condo fees lower, which means that you will avoid having to use a central system, which makes sense. I've done that before. We've done that before. But that also means that you're taking more load potentially on peak days from the grid, which when you have 50 buildings in one neighborhood and they're all getting fed from the same grid is going to cause issues and overloads probably for the entire grid. Did I get that right?
You've got that right, but it's worse than that. The utility doesn't take that lying down. Instead, when you call them and ask to be connected and you say, this is my load, I would like to be connected, they say, that's great. We have to build a new feeder for the neighborhood and you're going to pay for it. So
that's true as well. Yeah.
So if you and your neighborhood of 5 condos are all using double the load, you're all going to pay for the cost of that new feeder.
Wow. Okay. That's complicated. That's really complicated. But I understand what you're saying. Okay. So I guess do we see an easy way out of that? And I guess you have an answer for that.
Such a good question. I don't think there's any easy answers. You got to it before though. Have your mechanical and electrical engineers at the table early. Just have a talk with them about the neighborhood context, how much available electrical capacity is there. Really high level calculations to figure out if there's a conversation that's important to have here so that you can have it early. And that way you can start planning. You can start reaching out to the utilities early.
Understood. Okay, that's interesting. I've never thought about it like that, but I definitely see your point. And you're right. We go through it almost on all of our projects that you end up adding more load to the system, and hopefully they can keep that the juice in the system.
Well, it's fascinating. I'm just going to very quickly add that the way that many utilities handle this is that you tell them what load you need, and then you pay for it. After 5 years, they come back. If you didn't use as much as you said you were going to, they claw back the capacity, but keep your money.
Yes. They can.
They can. They can.
And they can. You know what? That's the type of service that they do have that type of leverage.
Well, what I mean is that it's really important to accurately describe to the electrical utilities how much load you intend to use for development. It's a really
don't pad it, don't overestimate it, and have it right. Okay.
Have it correct and have your engineers around.
Right. And going back to those high-level strategic decisions that you were mentioning, I'm going to use this as a segue and go into another discussion here. Is that so? Item and technologies and products. You mentioned products as well. Let's talk about geothermal, or what you mentioned that I've heard you talk about before. Geo exchange, I guess, is a correct word for what we're using right now. Is that a potential way out?
Yes. So geothermal or geo exchange is really wonderful. I will clarify for your listeners the difference. Geothermal is the technical term used by the electricity industry for high temperature steam derived from lava, derived from the actual very
really hot
water. This is like hot springs energy. So you can try and tap that even in Toronto. There are new drilling technologies based on fossil fuel extraction that are going to go 7 kilometers down looking for hot water. That is not what I'm talking about. When somebody says they're going to put geothermal in a single building, that is not the technology they mean. Geothermal or geo-exchange for a single building is a completely different technology. We could call it an earth-coupled heat exchanger. So what we're trying to achieve is we're going to exchange energy with the dirt under your building, which is not very good at moving heat around. So the big chunk of dirt under your lot or your building will slowly get colder and colder over the course of the winter as you suck energy out of it and put it in your building. It will not have warmed up by the time spring comes. So it is the job of your mechanical system to put heat back in all summer from your air conditioning system's operation to re-warm it for the next year. So geo-exchange is both an exchange technology, but it's also what we could call seasonal thermal storage. So you're actually taking the heat that you needed in the winter and putting it by for the next season.
Right. I've never thought about that way, but you're right. We're basically exchanging through the exchange. You're banking the energy, if you may, through the summer, used in the winter, and so on and so forth. Okay,
that's right. And so, this is really important because it means that your geothermal designer is one of the most qualified professionals you should ever hire. Because if they get that calculation wrong, in year 1 it'll be fine, in year 4 it'll be fine, in year 7 your building will have slightly too little heat, and by year 20 there's a giant block of ice under your building and your system doesn't work. So you need it to be sized properly. And you need it to be operated properly.
Can we expand on that? Because I always, whenever we have a project that uses geothermal, or I learned geo-exchange system on the project, one of my fears as a builder is that what happens if something goes wrong, or like you mentioned, there's an error somewhere. God knows, something else happens down the road 10 years, because we technically don't build these buildings to only last 10, 15 years. We build them to last, hopefully, for much longer than that, right? How do you fix that?
That's a great question. You can design a geo-exchange field to be more resilient. But the way that we fix it is usually by abandoning a well that's failed in place if the well has leaked, or by adding additional heat or cooling, depending on which way it's unbalanced, if you're seeing a change in the temperature of the field over time. So we've known developers who've had to add snow melt to their systems to be able to use some more heat if they were a heating dominant development. That would be something like an office building. A cooling dominant development. So there's too much heat in the field. My belief is that by 2040, this is another interesting thing about geothermal systems. By 2040, we're going to have a very different balance of heating to cooling required in our residential buildings in Toronto. So one of the secret weapons of geothermal buildings is that by 2040, there should be enough extra heat from summertime operation to heat domestic hot water.
So if I get this right, you're saying that because of global warming, we're getting much more heat and it's going to get warmer. So you can store that in the ground, basically.
Yes.
And then, okay, can I flip that? Will we be able to use it to cool down our buildings at that point?
You can. So the big advantage of geo exchange is that the temperature of the dirt below your building starts at 10 degrees Celsius and moves only as far away from 10 degrees Celsius as you force it to. So that typically means that you're seeing a swing from about 2 degrees Celsius in the winter to about 20 degrees Celsius in the summer. And so that means when all of your neighbors are trying to use a compressor to move energy out of your building at 21 C inside to a 31 or 34 or, I hate to say it, 43 Celsius is what we expect the design day temperature in Toronto will be by 2040. So you're trying to move energy across this 20 degree delta T. A person who owns a geothermal building will still be accessing that nice 20 degree Celsius earth under the building. So instead of having to move energy across a 20 degree Celsius temperature difference, they're moving it across a 1 degree temperature difference.
Right.
So in the springtime, some geothermal buildings can even do like a plain heat exchange. So you don't even have to run a compressor. You're just taking the cold water out of the dirt and running it through your.
Basically, as long as Toronto and Canada is habitable, because I think 43 and probably 50 is where you kind of stop seeing that much habitation anyways. As long as it's habitable,
we're going to be not that much hotter than everywhere else. It's all.
I know. Yeah. So geothermal is, I guess what I'm trying to gather here is that geothermal has a factor of time into it, whereas I don't think, or at least I have never thought of other elements in the building as a time factor. And by that, I mean that like when you design a chiller, I've never really thought about the 50-year life cycle, because typically it just breaks down and you fix it and you replace it with another one. But geothermal is not like that. You have to design it with a 20, 30, 50, 40-year time span in mind, I guess.
That's
correct. Did I get that right?
Yeah, that's right. At least a 20-year time span. I think that's the minimum required by code, but you should anticipate that system will be in place for 50 years. That's what we're trying to achieve with those systems. So we want them to be durable enough to last. They're really protected, right? So there's nothing down there that's going to be able to damage or destroy them. So they're protected from UV radiation. They're protected from big thermal swings, except for the ones that you're putting on them. So they're a really good, durable system.
And the thing that you mentioned about the snow melt is actually very interesting, because I always thought that, okay, if you have a geothermal system in your building or geo exchange system in your building, and if something goes wrong, like you said, you have to put something supplementary on top, put heaters, put coolers, or whatever you do. But you're right, like introducing snow melt, basically you're eliminating the cold or the low temperatures on top, which helps. That's a very smart way of doing this.
You could very, very comfortably, I think, for the majority of buildings, use the systems already in place to do a better job of cooling or heating to balance a field, as long as it's not very much out of balance. Yeah.
So
They do
it's not
require
that.
management though, right? So if you're not sure who is going to manage the field, if you're not sure what size of building it is, this is one of the real big benefits to having a long-term lease on a geothermal field, is that there is a guaranteed built-in third party who will watch the field and who will flag any problems, even if the owner is somebody who may be, because they're a smaller condo, may have difficulty doing that work themselves.
And by management, you just mean basically monitoring to see if someone is overusing the field or not?
Correct. Monitoring to make sure that the temperature balance has been maintained, and working with the condo or with the building to correct it if it needs to be.
Interesting. I'm learning a lot here. That's really good. I want to just quickly go. You mentioned product. You mentioned product developments and people having gone through that route. Does anything specific come to mind when you're saying in the past 5 years, maybe some new products? Do you have any specific example we should be talking about?
100%. So the two big ones for me are heat pumps, and then energy recovery ventilators. So I'll go in order. Heat pumps move energy from one place to another. Air conditioners are a heat pump that only go in one direction. They only cool the building and heat the outside. If you put a reversing valve in that, then you can cool the outside and heat the inside. So that's our big decarbonization technology here in Ontario. And that's true because we have done a pretty good job of decarbonizing our grid, especially off peak. On peak, we're still burning a lot of gas. So there's things to be said about that. But heat pumps have gotten better in a number of directions. Number one, they provide heating to colder outdoor temperatures. So the big problem with a heat pump is that the larger the spread of temperature they're trying to operate over is, the less efficiently they do their job and the less energy they can move. So if you look at a boiler and you're sizing it for a peak day, you say, well, okay, it's going to put out 100 MBH, right? And so minus 20 will put out 100 MBH. Minus 25 will put out 100 MBH. Minus 30, same. With a heat pump, if I size it for a design day, minus 20, 100 MBH. Minus 25, 50 MBH. Minus 30,
Right.
It turns off and can't heat the building. And so that's pretty terrifying for me as a mechanical engineer, because it means I have to either oversize the system or provide backup. And there are more and more heat pumps on the market that are maintaining their temperature output to cold enough temperatures that I don't have to buy backup, and that I can modestly oversize them and still meet the whole building load. And not only that, they're doing it with a wider variety of indoor delivery methods. So it used to be that the only cold climate heat pumps required that you run refrigerant pipe through your whole building. So fugitive emissions are a really big problem. R410A is the most popular air conditioning refrigerant, and it has a climate change potential 1,800 times worse than an equivalent volume. And the way that heat pumps work is that there are huge pressure swings inside the systems. And refrigerants, the whole definition of the word refrigerant is that it's a substance that goes from gas to fluid and back again regularly as part of its operation. So we have no way of detecting a leak because we expect to see huge pressure swings throughout the system. We can't measure how much refrigerant is in one of these devices until it's basically all gone. And then often you'll refill it.
Sounds alarming.
You'll refill it, then you'll be like, okay, I found the leak, you'll refill it, but you'll be wrong. And so you often lose 2 charges in almost its entirety when there is a leak in one of these systems.
But basically what you're saying is that if I try to do a good building, build a building, good design on the building, use the proper equipment, which is presumably a heat pump, but I'm using a heat pump that uses refrigerants, even if I try my best and it's still going to have fugitive fluids or gases that are going to leave the system, the damage that is done because of that fugitive refrigerant is probably going to offset everything else I've tried to do.
I would say it will partially offset some of what you've tried to do, for sure. Yeah.
Gotcha. Okay. So
there was
not a good thing.
I was going to say, there's a building, one of the most energy efficient buildings that was ever tried in the province was built by an engineering company called Intermodal. They did an original building that had hydronic in-floor radiance coupled to geothermal heat pumps for the first building. Then they built a second building and it was all variable refrigerant flow air source heat pumps that had full refrigerant-based distribution. So each indoor unit is hooked by refrigerant-containing pipes up to the outdoor units. And when they lost the charge in one of their systems, twice, because it took them a while to find a leak, they found that that was worth a year of their carbon savings.
Wow.
So the thing is, that's right. Well, it is, but the building will be there for 30 years. So 29 years of their savings are still okay. But I don't love that liability. So I'm trying to design buildings where if I'm using variable refrigerant flow systems, I'm using them in compact layouts, easily accessible pipework. I'm using them in places where I know that the system is going to get replaced regularly anyway. So think about leasable spaces like office buildings or tenant fit out spaces. That's a place where that kind of risk makes a lot of sense. When I'm looking at a building that's going to be there for 30 to 50 years, I've really started thinking about, when I do walkthroughs of existing buildings, which systems do I see that are still original? Hydronic systems, fan coils, baseboard radiators full of water. They are 50 or 60 or 70 years old, and they're still the original pieces of equipment. We've maybe replaced motors and pumps. And that's very exciting for me, because those are still systems we can use today. So yet another advance in air source heat pumps is that we can now couple an air source heat pump to a hydronic system. And there's variable...
So basically sorry to interrupt, but you're basically saying, hypothetically, we could use the same old-fashioned or even old radiators that have water in them, but instead of heating them up with fossil fuel, we can do that with a combination of air source heat pump and potentially geothermal.
You've got it. That's it.
Okay.
I was going to say, intense. So for me, that's the dream, because you can hear the worry in my voice around these refrigerants. So the fewer refrigerants we have in the system, and the better for the environment the refrigerants are, the better we are doing for the planet. At the same time, we know that heat pumps, I haven't quantified this for you yet. We know that heat pumps are 20 times better for the environment than a natural gas boiler in the Ontario marketplace today.
Sorry. So let's repeat that again. So heat pumps are 20 times better than a natural
gas furnace. So natural gas furnace. So you're going to have about 5% of the carbon emissions for heating if you're using a heat pump compared to natural gas appliance.
So it almost is a no-brainer, is what you're saying.
From a climate perspective, we want to be using heat pumps. The question then is, which heat pumps? And from a nuanced perspective, what's the refrigerant charge? And as a developer, you don't have to certify your building to LEED. And in fact, you and I are working together with a really interesting and innovative company that exemplifies the thing I'm about to say. You don't have to use LEED, but it's worth saying out loud that the Canadian and US Green Building Councils have, for over, I want to say almost 20 years now, been creating standards that describe best practice environmental features of buildings and describe in detail how to ensure that you incorporate those into your building. So the benefit when I've worked on LEED buildings, LEED certified buildings, is that I have never worked on a LEED certified building where we didn't have to go back at the end and fix something because a feature we thought we had incorporated didn't actually get built the way we hoped it did.
A feature that you thought had incorporated didn't get built because of site conditions or something on the construction process.
Something on the construction process, something on the design side. Yeah.
Gotcha. So, and I guess this couples with, like you said, on the project that we're working on right now together, with a lot of it, or maybe 50% of the project being modular, prefabricated off-site, we're reducing that risk by some degree. There will be still there. Yeah, some items will still be on site, but you're right. I hear where you're going.
Well, and we've also on that project, we have a list of environmental standards we're hoping to hit. We're not certifying the building to LEED, but we are using it as a reference point for using best practices in our building. And we've done that with a bunch of things. So we're doing some Energy Star standards, looking at, I think, Fitwel standards. So there's a bunch of different high performance, environmentally friendly things we're doing. And we've used the certification systems as a reference point for what best practice is. The reason I bring that up in this conversation is that LEED for more than a decade has helped building owners quantify whether the amount of refrigerant in their buildings is small enough to be environmentally friendly. So they've set a threshold.
Right.
You can just calculate based on the equipment you selected whether or not you're lowering the amount of refrigerants in your building enough to qualify as an environmentally friendly design.
I want to emphasize something you mentioned here that I think is really important because, like you said, LEED has been around for quite some time and a lot of people have done it. But one of the things that I've personally experienced, especially working with smaller projects, smaller development teams and smaller, call it some entities that don't do 10 projects a year, maybe they do one project every 5 years, that LEED sounds like this whole big scary thing that you don't want to go toward, you want to stay away from as much as possible. But at the same time, and I want to use this as a segue to a whole different part of the discussion, is that at the same time, we just talked about the climate change and the fact that it's not a theory anymore, it's not in the news anymore, it's not in the books anymore. You see it, you breathe it every summer, at least in Toronto we do, and then many other parts of the country as well. But at the same time, you don't need to go and pursue LEED certification. But as long as you're aware as a developer what you're doing, what you're planning for, what the impact of your building is having on the environment, it gives you an edge. And maybe you can make some cheaper decisions, which can have bigger impacts. Like you can get a pretty decent ROI, at least in terms of sustainability of your building and climate control. Can you think of any of those decisions? Like we talked about a whole bunch of technical stuff, which are pretty complicated compared to what's going on in the 80% of the industry, which is not using the dew exchange or which is not using heat pumps yet, right? I shouldn't say many people are using heat pumps, but there's still other types out there. Can you think of any low-hanging fruit, any easy wins that people can do? So you know what, next project, if we do these 3 things, it's going to be relatively cheap and we still can be better.
Good question. You, on the last topic, asked me about technologies I was interested in, and I said air source heat pumps, energy recovery ventilators. So I'm going to re-up on energy recovery ventilators as a quick, easy win that I love to see in projects. So an energy recovery ventilator is a way of getting fresh air from outside directly into a single space in a measured way. And then you are heating that air using exhaust air from the same space. So the benefit of this device is not just an energy savings. It's fresh air and indoor air quality and safety. So coming out of COVID, we need to be able to know that we're providing air that's safe for occupants to breathe. Changing it with the outside does that for you. And having a high performance unit will recover both humidity and temperature. So you're going to be able to do a better job of maintaining healthy indoor humidity levels, which again, research that was done during COVID showed that if you can maintain humidity levels closer to 40%, which most Canadians know is really hard in the winter, but an ERV helps, you're going to reduce people's chance, according to this research, of acquiring respiratory infections by over half. So this is a device that provides health benefits, that provides building science benefits because it's giving you that kind of constant humidity level and it's saving you a ton of energy for a very small incremental cost over the minimum code standard feature in the building. So you're going to have to bring ventilation in anyway. That's right.
Yeah, it meets the criteria for an easy win, relatively easy win.
Easy win. And so this is another place where I like to reward people who are doing well. So when you're purchasing mechanical equipment, a lot of cost competition happens. So a lot of the equipment is almost the same price. You can reward people who've done the work to get the higher efficiencies by giving them your dollars and buying their products.
Buy the better product for the environment.
Buy the better product for the environment. And then if you're in Toronto, you get all sorts of exciting knock-on benefits, like the energy recovery ventilator allows you to trade off with windows. So it may help you with the cost of your building envelope. Another related strategy that's incredibly helpful, this is so important, air tightness. Here's my pitch for air tightness. If you look at insurance claims in the first 5 years after a building is built and turned over, you will find that water damage is one of the most important single sources of claims. Water comes from two places: me, the mechanical engineer, who we can talk about that later, and the outside, getting in where you don't want it to. Anywhere that air can go, water can go. So if you invest in air tightness testing as part of your development process, you will find holes in the building envelope and fix them before water does it for you at a cost of hundreds of thousands or millions of dollars of duration.
Damages. Look, this is all common sense. Like if you can find a leak, you have a leak. It's leaking air for now.
It sounds like common sense, right? But we don't do it. So the city of, I think it's Seattle, decided they were going to incorporate air tightness testing into their building code, but they weren't sure what standard to set because nobody did the testing. So the first year that they ran the program, it was required that you submit tests, but there was no standard, right? You see, the number could be anything. You just had to say that you tested. They found that from the first to second building that a single general contractor did, there was over a 50% reduction in the air leakage in the buildings that they submitted.
Just by paying attention to it, probably.
Just by paying attention to it.
Yeah, I know.
If you don't measure it, you can't fix it. It's so important. So it's not a mechanical thing exactly, but as a mechanical engineer, I'm oversizing my systems because I don't trust the building envelope to keep the outside out. If you can guarantee me an air leakage rate because you're going to test it, then I can reduce the size of the mechanical systems and put money back in your pocket. So that's another place that's really interesting.
So I want to go full circle here. Sorry. So I'm a developer. If I invest in a better building envelope, I'm going to get less air leakage, which is going to then make you feel better about not over designing my system, which means that I pay less for my equipment and I probably pay less during the course of my maintenance of the building, and my condo fees are going to be lower, right? And consumption is going to be better. Okay, what did I miss? And
you're
overall,
missing. So if we all remember the leaky condo crisis in Vancouver, you're significantly reducing the chance that you and your building will be one of those exciting news studies because there's a failure in your building envelope that you were not able to detect as part of your development process.
So you could, by incorporating air pressure, air tightness testing or design and testing,
correct,
you get multiple benefits. Okay, we're learning a lot on this episode today, which is great. But I want to use this, and I want to segue into something else. You have a presentation online, like you and I were talking before, and I'll put a link in the show notes for people who are listening. They can find it on YouTube under, I think it's called Better Building Bootcamp, and I'm going to ask you to explain on that what that whole concept is as well. But in the presentation, you talk about the goalpost for high performance design to be evolving, going from just an energy efficiency to operational carbon and embodied carbon, and maybe walk us through that evolution. And I'm going to piggyback off of the same question and say, where do you see this evolution going by 2040?
Yeah, I mean, we already covered this by 2040 situation, right? So if we cannot prevent emissions by 2040, we will miss the window to limit the severity of climate change. It's no longer about, oh yeah, we'll do it, but maybe we'll do it in 2060. A kilogram of avoided emissions today, I don't know the exact numbers on this, but is worth 2 or 3 kilograms of avoided emissions in 2030. It's worth 5 avoided emissions in 2040, because every year from now until 2040, we're not warming the environment. So that same kilogram of CO2 in the atmosphere does 15 years of damage if we emit it today, only 1 if we emit it in 2040. Embodied carbon, as our building's operational efficiency gets better, becomes incredibly important. So embodied carbon is the amount of emissions associated with the manufacture and transportation of the goods that we use to build the building to the site. So they're all of the emissions that are front loaded. They've happened by the time you move in day 1. everything has already been emitted, and it's going to has done that climate change damage and continue to work in the atmosphere for the life of the building. So
and it's all gathered in the material you're using, the transportation that is happening, and the method you're putting it together, right?
You've got it. That's it. So if you trace a kilogram of concrete from the moment that somebody touches, their shovel to dirt, wherever that concrete was extracted from the ground, and then it was processed factory, and then it was put into the truck and brought to site, all of the elements, even the workers who had to drive to site to be able to build the building, all of those emissions are embodied carbon. And then operational carbon is the emissions that happen after you move. So if you use wood instead of concrete as a single example, and this is a little complicated, wood in particular, wood is actually frozen carbon, right? Wood is primarily made out of carbon. So you've definitely taken carbon that was in the atmosphere and you put it in your building and you sequestered it. So for the lifetime from now until 2040 is not going to be in the atmosphere anymore. The only issue is that tree was growing and it was removing CO2 from the atmosphere every year, and now you've cut it down. If you've done that responsibly in a well-managed forest, then you likely have not impacted the year-on-year sequestration of the forest. If you've clear-cut a forest, it's not just that tree that's no longer absorbing carbon, but all of the ecosystem that was around it. So trees are a complicated issue, probably too complicated for a mechanical engineer.
I was just going to say you're touching on a topic that I totally agree with you. I'm not a mass timber specialist with all the mass timber that's going on by any means, and I'm pretty sure I'm going to have an episode about that particular issue, because you're right. Like even in my mind, I've always been, okay, we're cutting trees to save the environment. I'm sure there's a fine line somewhere that I haven't seen yet, but I totally hear you. But to go back to what you were saying, so basically we're trying not to burn fossil fuel, which is helping with your operational carbon emissions. And then we're also trying to, first of all, not build a building that means doing more emissions. When during the process of
this is for developers, right? So let's back up even more. We don't need to talk about whether we build quote unquote it from concrete. When you're a developer, part of the decision you make is what is it? So a swimming pool has 4 times the operational emissions of a golf simulator. So if you're trying to choose which amenity you're going to provide, having an understanding of the operational carbon, the embodied carbon required to build certain kinds of amenities is really important. Putting time and energy into looking at the efficiency of your building, which you're already doing for economics reasons, right? The difference between a 73% efficient floor plate and 85% efficient floor plate is this like 10% of the building.
Yeah, it's massive.
It's massive. You didn't sell it. Nobody's living in it. And you had to build it, and you had to, expend the carbon to create it.
Yeah. You have to keep it running.
That's right. You and I, again, are building, we're working on these projects where we've stopped going below grade, which is fascinating. It's a really interesting change. If we're trying to do buildings that are 6 or 8 stories, staying out of the below grade area and finding different solutions to deal with parking substantially reduces our overall embodied carbon footprint. And it has nothing to do with the material choices. We've gone earlier than that. And we've asked, what are we building?
Whatever. And that has been, in my book, that has been a very significant win over the past few years that City of Toronto is now allowing these types of buildings, because I've been part of many projects, probably too many projects, that we had to just do underground for the sake of doing the underground, and it didn't really help anyone involved in the project. It just made it more expensive, less affordable for everyone, and a lot of environmental impact. Talk about groundwater table, talk about emissions, like you were saying. So that definitely is a good item. And so let's talk about that now. If I were to give you a magic wand here, and someone could give you a magic wand here and say, Cara, here's your magic wand. You get to make one wish. And with that one wish, you could change something. And I'm going to say something in the area of either regulations and laws where it comes to building buildings, or mindset or design guidelines. And I think as it pertains to you, and say, you know what, tomorrow morning, everyone who's designing building as a mechanical engineer needs to do this, or everyone who's a developer and wants to go for a building permit application needs to do that. Do you have is there anything that you think, what, if they could only do this one thing, it will have the effect, at least makes a dent in this whole big monster?
I wish there was one thing. It would be a lot easier if there was one thing, right? If you do a single thing, make it heat pumps. But everybody's doing that. So I don't have to wave a magic wand. People have made the choice. In the city of Toronto, it used to be 15 years ago, you'd asked me that question, I would have said, window to wall ratios can't be 80%. That's not reasonable. You are building what one of my architect friends called ice cube trays in the sky. If you looked at a building from the early aughts and you looked at a car radiator, you'd be like, oh, that's the same design. Got these beautiful concrete fins sticking out through the building envelope. It's got an R2 wall and it's got absolutely no opaque area. But, Lisa King and her team at the Toronto Green Standard have, over the course of the last 10 years, substantially impacted what we build. We regularly see 35, 40% window to wall ratio, which is enough to get you beautiful daylight, glare-free daylight, by the way, because 80% window to wall actually creates glare. It creates discomfort issues. When you drive by condos with that much window, I challenge you to look and see how many blinds are closed. You're going to notice that a lot of them. People don't want those. I mean, they want the windows, but they don't actually use them. So I would wave a magic wand and change that, except for that's already been changed. So I think it's got to be airtightness. I think if I had if I had to wave a magic wand to make one thing happen, it would be airtightness. And the standard to look at is Passive House. You don't need, just like I said, you don't need to certify a LEED. You don't need to certify a Passive House. But if you target their airtightness targets and you look at their detailing and you follow their start to finish process for making your building airtight, you will find that your construction quality goes up and that your risk goes down while you simultaneously achieve energy results that didn't require spending any extra money on materials.
It does sound like one of those things that could move the needle just enough to make other things happen. It sounds to me like it can be the first domino, if you may, that can lead to other things, right?
If I had more faith in the world, my answer would be, I want my building automation system to be as good as myself. That would be what I would say. Because
your building automation system to be as good as yourself. And what does that mean? What does that like?
I can almost give do you remember programming VCRs?
Yeah, a long time ago. Yeah.
Have you ever given an iPhone to an elderly person? It's a lot easier to teach someone to use an iPhone than it was to program a VCR, despite the fact that what you're getting out of the system is much higher quality. There's way more content, way more functionality available, and yet the user interface is smooth and easy to understand. And our building automation systems are not there yet. They're not smooth and easy to understand. The people who get to interact with them and the functionality that they get out of them is not high enough that they are regularly used to let people really manage their energy use and their mechanical systems. And what that means is that I get phone calls and people say, our bill's been really high for a little while and I don't know why. And, you go and you look and their cooling tower and steam valves have been full blast for 6 months. So they've been fully heating the building and then simultaneously blasting that heat out the top of the building. And the automation system technically told them it's not friendly enough to actually throw up an alarm that's clear and straightforward. So,
So for those people who are listening that have those capabilities and those abilities, here's an opportunity you can work on. And I just want to try and wrap my head around the whole, like we talked about a whole bunch of things which are really fascinating here. And before we go, I do want to touch on Passive House for a second before we sign off. But it almost sounds to me like, and because I'm a big believer that the market forces and the economic factors are probably the biggest lever that we have as a species when it comes to implementing change. Meaning, if enough people feel that there is money or loss of money in something, then that thing starts happening, right? So with everything we just talked about, basically from decarbonizing an existing building or picking the right mechanical system or air tightness testing and everything we just talked about, it almost feels like, and I hate to say this because it might involve more government, and I don't advocate that, but it almost feels like we need someone to say, you know what, here are some new guidelines, and I'm saying it, and I'm just saying I don't think we need more guidelines, but I don't know. What are your thoughts on that?
So I have family history with this. So one close relation of mine worked for 10 years on the R2000 program, which was an optional industry-led certification system that set a lot of guidelines for low-rise housing, low-rise energy-efficient housing. But they advocated strongly to not make it regulation. And the number of R2000 houses that were built over the course of that program's run was not high.
Right.
Trusting the market to, putting no serious incentives in their path is not going to get us where we need to go. I think the Toronto Green Standard, I can see the changes it's made in the marketplace. And not just in Toronto, but in all of the developments happening around Toronto. If you work on a condo in Oakville, it's got energy recovery ventilators and it's got a 40% window to wall ratio, even though they didn't have those guidelines as early as Toronto did.
It is percolating.
It percolates. So I think that very, very straightforward, very easy to accomplish regulation has its role. I also think we maybe need to get the right regulation in place. We spend a lot of time on things like groundwater management, and I feel like
we do.
I would love to see more regulation focused in the places that, by 2040, we are sure are going to save the planet. If we had to narrow in on specific parts of these guidelines, it's all about iteration. So we've been promised by the current government that they would work on streamlining things for developers. And as a developer, I'm sure you have feelings about how streamlined things have become. And I just we need to keep working on making it more streamlined. That's not my area of expertise at all, but
it's work in progress. Like I said, like you mentioned, the whole thing with parking and not having to go underground, that definitely has been a good move.
Win. It's a big win.
It's a very big win.
They're huge wins. I'm being serious when I say that if you look at the combination of shutting down our coal-fired power plants, regulating car emissions, we just don't have smog days anymore, and we used to. We don't have acid rain anymore, which was a thing when I was a kid. The hole in the ozone layer is closing. All of those things were accomplished by regulation and by government action.
So we need a little bit more government in these areas, at least.
The private sector has a huge role to play, and the decisions we make in the private sector are incredibly important. So I want your audience to know that they have the opportunity to lead the industry, and that the places where they can lead will give them market advantages. So the thing for me as a mechanical engineer is that a lot of the things I'm advocating for really do create tangible changes in the way that we interact in our houses. I think we are at a real disadvantage to the car industry. If you go and sit in a high-end vehicle, you feel the way the doors close. You can breathe the indoor environment. You can see that you have these different ways of controlling your climate. I have a friend who's got in-seat air conditioning, and he swears he's never going back. This is the best thing that's ever happened to him. And we get to tangibly experience those vehicles before we buy them. And we don't get to do that with condos. And even if we do, we don't put the energy into making sure that our model suites have the energy efficient and high performance features that are going to make a difference. And we don't put them next to the basis of design code compliant suite. If you put a heat lamp behind a triple glazed window and double glazed window, you can just move your hand from side to side and see how much heat is not getting through. You can feel the acoustics. You can put a speaker on either side of a triple compared to a double and like let people experience that. You can put a PSC motor at about half the price and double the noise next to an EC motor. You could build the worst suite known to mankind. And I mean, no, but can I tell you a thing about a code compliant building?
Please.
A code compliant building is the worst building you are technically allowed to build. It's the absolute limit of the worst building you're allowed to build.
Is that the definition of a prison cell?
Technically a code compliant building. I mean, so if you are building better than that, though, you need to get your marketing team involved and like let them experience those tangible benefits.
You just threw out some very good market. I just took notes of them because you're right. Like, I know not too long ago we visited the sales center for someone in Vancouver, and they were trying to promote the difference between that was actually mass timber system, and they, like you said, they had these two chambers with two different wood structures, and there was a physical hammer, someone up there, I think it was mechanical, was just banging on the wood to see, so you can see how much difference in two rooms you get. So that was
that's so cool. Yeah,
it is. Yeah. It is. It didn't work really well in that instance, to be honest with you.
And this is the thing that I'm flagging is that like because we're not good at doing it, we haven't tried to figure out those sales techniques. We are at a disadvantage. It's the same thing for mechanical equipment. I'm very frustrated that I can't buy something that looks as good as right? If you say to me, Cara, I know people are going to be able to see this piece of outdoor equipment. Can I get one that's nice? The answer is no. Nobody makes one that looks nice. The industrial
not even on the inside. Right?
I mean, it's fine if they don't look good on the inside, but like we should be able to have things that look nice. I want to like call out LG specifically. If you look at the indoor units for their mini splits, they've put some serious effort into like making some decorative ones, but they're about the only people in the industry. Yaga is another example of like a hydronic manufacturer who's got some interesting finishes, but I can name them on one hand because there's very few people thinking about the way that we make people excited about owning high performance things because they feel good and they like give you tangible touches of luxury.
My hope is that, based going back to what you had mentioned before, is that in 5 or 10 years from now, hopefully if we're doing this discussion again, it's not considered high performance anymore. It's considered basic requirements. And who knows, maybe that would push people to come up with more innovative designs. And I'm hopeful that it will. And at that point, who knows? I'll let you know if I find a equal to Porsche design for a unit outdoors. I want to start to wrap this up. This has been very informative. I've really so many things here that I can go back on, but we're going to sit here for another 4 hours. But if people, first of all, is there a resource that you would go to as your own go-to resource that you would go back to read regularly and say, you know what, this is where, what's a website, it's a newsletter, it's newspaper, whatever, magazine, that you consider a resource for yourself? And yeah, can you share that with our audience? Does anything come to mind?
I mean, ASHRAE, my professional organization, is one of the key websites I go to. They publish mechanical engineering research, but also guidelines. They've got an entire guideline on indoor air quality. They've got net zero design guidelines that are free and easily downloadable. So if you're doing a very small building and you don't have money for a sustainability consultant, you can download that and have a look at it. So yeah, I love a variety of their website resources. They're a touch engineering, but if you can get past that, they have really good information.
I can imagine. They're typically very technical. Okay. Is there any question that I didn't ask you, or is there any final thoughts that you would like to share with our audience here before we sign off?
No, I think that you asked a wide variety of really interesting questions.
Thank you very much. I'm happy you enjoyed that.
No, this has been great. I hope that it's interesting to your audience. It went a lot of places.
It did. It for sure did. We started from philosophy. We didn't go into martial arts. Maybe we keep that for round 2 of this episode.
Absolutely. You don't know how badly philosophers who do martial arts can go on tangent.
It's an interesting mix. But thank you very much, Cara. I really appreciate you doing this, taking the time. It was really informative, and thank you very much. I'm sure our audience is gonna find a lot of value in this, and maybe just share with us where can they find you, or if there's any website or links you would like them to know.
Absolutely. So again, Cara Sloat. So I'm a mechanical engineer with Hammerschlag and Joffe. So our website is hamjoff.com. And you can also find me on LinkedIn. I will share things that I find interesting, including those ASHRAE resources, but also webinars on a wide variety of topics. I also am on the board of the Toronto 2030 district, but they are working to decarbonize the entire downtown core. So if you are a person who owns a building in the Toronto downtown core and you would like support in decarbonizing, we are currently looking for participants in our pilot project.
And maybe, do you want to maybe just expand on that before we sign off? What is decarbonizing of an existing building?
So decarbonizing it of an existing building is adding a heat pump to an existing building. And then if you wanted to look at my other technology I'm passionate about, we did some research that was funded by the ISO that showed if you add energy recovery ventilators to an existing building system before you add the heat pumps, you generally get an improved ROI. So your financials get better because you can reduce the heat pump size enough to pay for the energy recovery ventilation improve.
Interesting. That's a very interesting definition. Thank you very much, Cara.
Thank you so much. I
appreciate this. Have a great one.
Absolutely.
Talk to you later.
You too. Bye.
Thank you. Just one last thing before you leave. We have developed a comprehensive guide of resources that people in the industry are using to make better decisions or keep themselves on top of the trends, learn about new products, technologies. These include books, websites, blog, podcasts, YouTube channels, apps, and softwares. And people are using them to make better design decisions, investment decisions, or engineering decisions. And I'm sure that you're going to find this very helpful, but hopefully it will save you dozens of hours when you need it. And who knows, maybe even more. This is a live document that we're going to keep updating every few months. Please go to our website, realestatedevelopmentinsights.com, and you can get a free copy of this document for yourself, realestatedevelopmentinsights.com, to get the free PDF resource. Thank you very much.